Welcome to Ask and Learn.
We are given a non-deterministic finite-state automaton, and we are asked to find the language recognized by this machine. So this is the machine from exercise 44 in this section. Looking at the figure, we see that it contains three states, S0, S1, and S2. We see that S0 is marked as the start state. And we see that the start state is also a final state. Because it's a final state, this implies that the empty string lambda is in the language recognized by the machine. Now we see that to move from state S0 to the state S1, which we see that this is a final state, first let's consider the possibility that we do it directly. And the input must be a 0 or a 1 at state S0. So it follows that the strings 0 and 1 are also recognized by the machine. Now instead, suppose that we want to move from state S0 to S2. Which is not a final state, and the input must be a 1. Then, once we're at S1, once we're at S2, to move from S2 to S1, the input needs to be a 0. And this is to move from S2 to the final state S1 directly. There must be an input of 0. Notice that there is a loop at S2 for input 1. The string needs to have at least one 1 before the 0 to go from S0 to S1 to S2. So in other words, all strings of the form 1, 1 star, 0 are recognized by the language, by the machine. They're in the language for the machine. So we have to have at least one 1. And this covers all the cases, and so it follows that the language generated by the machine includes the set containing the empty string union with the set containing the strings 0 and 1 union with 1, 1 star, followed by 0. And we see that the first two sets here can be combined to give the set containing the strings lambda, 0, and 1, union with the set containing the strings 1, 1 star, and 0.